Hey everyone, and welcome to the final video of Lecture 11, and this time we're going to be looking at energetic materials, what they are and what they're used for. And this kind of follows on a little bit, well, it's more related to the P block chemistry and especially the nitrogen containing compounds. Now with this one I'm hesitant to say that it's looking at how we can solve societal problems with energetic materials. In fact, half the time I'll be showing you that energetic materials, if they're used in the wrong way, actually are a societal problem. But they also can be used for good, and especially to facilitate human interest and things like space travel. So what is an energetic material? Well, it's something that has a lot of energy or potential energy contained in it that can be released, and that's usually explosively. So energetic materials are essentially things that go bang, and they're really useful for a variety of things: jet fuels, rocket propellants, and military applications. Which is why I say they're not solving too many societal problems, and in fact maybe possibly causing some. So I've got two very common ones you might have heard of before down the bottom: trinitrotoluene, which is TNT, and nitroglycerine. And as I was saying, it's kind of linked to the P block chemistry and nitrogen chemistry, because you'll see a lot of these energetic materials contain nitrogen, especially these nitro groups. So why is it that they always contain nitrogen? What is it about nitrogen? Well, the nitrogen triple bond has a really high bond enthalpy. So this NN triple bond in N2 in nearly 1,000 kilojoules per mole is actually the strongest bond there is. And when you compare it to nitrogen containing single bonds, stuff like an NN or an NC or an NH in these organic energetic compounds, they're quite low energy. So when you blow up one of these energetic materials or break the bonds of it, and it forms the nitrogen triple bond when it makes N2 as a product, a lot of energy is released because of it, and that's why they're energetic materials, why they explode. It's important to note that a lot of reactive hydrocarbons are also used, like completely not nitrogen containing things as well. For example, kerosene is used as jet fuel in jet planes, and also in rockets it's been used as well before. Kerosene with like liquid oxygen as well. So it's not always nitrogen, but I thought we'd focus on nitrogen because it's got this really strong bond enthalpy when it's as an N2 molecule compared to the single bonds it makes in these energetic materials. So one place energetic materials find their uses is as explosives. So as I said, this can actually be a cause of societal problems rather than a solution, but it depends how they're used. They don't have to be a bad thing. So explosives and energetic materials, nitrogen containing compounds, find use in both military and civilian applications. So on the left we've got RDX here. It looks quite similar to the TNT, trinitrotoluene, I showed you earlier, in that there's a hexagonal center unit with 3 nitro groups coming off it. The difference here is though that the central group isn't toluene, so it's not benzene with an extra methyl group. It's actually got more nitrogens, because in general more nitrogens means more explosive, and it's actually made this weird sort of not cult, but this subsection of research that is looking into novel energetic materials. They're actually trying to make compounds with as many nitrogens in them as they can. It's like the more the merrier. And researchers, when they've managed to put sort of like 14, 15 nitrogens, I think they can, in one molecule, they're quite pleased that they've managed to make a stable molecule with so many nitrogens in. But RDX is one of the bad explosives. It's a military explosive and one of the most widely used ones. It was used by both sides throughout World War II. Thousands and thousands of tons of it were made. And it's kind of used now as a benchmark. Like if you make a novel energetic material, it's almost like, it's so many times more energetic than RDX. As I was saying, the explosives don't have to be killing machines. They don't have to be bad things. We can use them for good. So on the right, I've got nitroglycerine back again. So this is one of the major components of dynamite. And dynamite's used a lot in mining and demolition. And although, we look at them now, and mining and demolition don't look so good. They create a lot of CO2 and they're a lot of destruction, even if it's controlled. But we wouldn't be where we are now without them. So although burning fossil fuels is bad and it has led to this whole climate crisis, 200 years ago they didn't know that. And you could say, without coal, without the Industrial Revolution, and without all the energy that we got from mining, society wouldn't be as we know it now. So if you use explosives in the right way, do it safely for civilian applications, they have actually benefited us through the last 200 years. And demolition as well. There's been there was a lot of reason to blow up some buildings in a controlled way, to make way for new ones, to make way for greener buildings in some cases. I mean, they'd have to be a lot greener for it to offset the demolition of an old building. But there are good uses for energetic materials as well. Now, the other use that I'm going to look at is as rocket fuel. So again, this is another one that can have good sides and bad sides, military applications and civilian applications. And I've got two examples again down the bottom. So the first one is this Cl20 molecule, which I put because I think it's just another amazing example of people managing to make molecules with as many nitrogens as they can. So it's got two pentagonal rings and a 6-membered ring, all put together with nitrogens every couple of atoms, and then again these nitro groups, because nitro groups are really energetic. This is a Chinese developed solid explosive, but it's never actually been applied. The thought is that it could be used as a missile fuel or sort of military rocket fuel, but it's never actually been applied. But solid explosives and solid energetic materials are quite often investigated for rocket fuel, and even the space shuttle and the space shuttle launch system with its boosters and that, they were all solid based fuels for them. And that is the civilian side of things, spaceflight. So on the right hand side again, we've got a couple of nitrogen containing compounds, this time much smaller, and these are liquids. And we actually talked about one of the combinations in the P block lectures, and that was of the dinitrogen tetroxide and hydrazine. So dinitrogen tetroxide is a really strong oxidizing agent, and if you mix it with any of these three other nitrogen containing compounds, you get a really explosive reaction. But they're commonly used in space travel for rocket launching systems as well. So that's the final one I wanted to touch on applications of inorganic chemistry throughout the world.